Okay, sometimes you have problems where you look at a graph and you have to come back with a possible function for that. If you see right here, there are two ways we could look at it. One would be a sine wave, the other would be a cosine wave, and definitely had a shift to it. Okay. Sometimes the easiest thing is to identify some parts that you definitely know. If you look right here, what I'm graphing out now is a sine wave. Okay, that's the apparent function to a sine wave, right? Now clearly, if it's right there in the middle, it went pi force over. Okay, so what if I were to ask you a few things? What if I wanted the vertical shift, the amplitude, the phase shift, and the period? Those would be the big components we're looking for, right? The frequency, I don't really care right now. Okay, the vertical shift was clearly at 4. That midline determined that right there, didn't it? So my vertical shift was at 4. My amplitude was clearly, what's that, 6 above and 6 below. Okay? Now my phase shift was definitely pi force to the right. Okay? And my period, this one's a little bit trickier, but I try to draw it neatly. If from here to here is pi, wouldn't from here to here also be pi? So the period, sometimes the trickiest thing to find, is pi. Okay? So if I'm drawing a sine function, I'm going to say y equals amplitude 6 sine, and I'm going to put plus 4 right here. And right here I'm going to think for a second. I know something's going to go in here, right? I know it's going to be something x. But the problem is we had a period of pi. So if you think back, if we had an x or a theta, and we had 2 times that, do you remember it's going to be the standard period of 2 pi divided by 2 if it's multiplied? That's kind of the tricky part probably, but that's just what it is. Hold on one second. So what I'm going to do right now is look at it differently. If I know I have pi force for a phase shift, I'm going to say x minus pi force. And if I put a 2 right there and I multiply out, do you see how I have that 2? That gives me the period of pi. So I'm going to say 2x minus, what's that, pi halves? And there we go. This would be my regular sine function. Here we go. That makes sense? Now, just to prove it, let's say we're unsure and we're like, I'm not really sure, I want to get it right. Let's make an XY table. Okay? Now, we kind of did it the quick way. I mean, obviously, I guess I walked you through it, but there's a very concrete method too, more so to check right now. But let's say we think this is right and I want to double check and be absolutely certain. Okay? So what I'm going to do is just pick any arbitrary value. It doesn't matter what I pick. For right now, why don't we pick a pi halves? If I pick a pi halves and plug this in directly here and do the math out, I better get a 10 out of it, right? So let's see if that works. This is just a test point. Pi halves right here. You ready? I'll do the math down here, okay? Hold on. I can do this. Let's see here. I don't need that. Okay, let's do the math. So I'm going to say 2 over 1 times pi over 2. That gives me pi. Pi minus pi halves. Pi is the same as 1 pi, which is the same as 2 over 2 pi. 2 minus 1 is pi halves. So if I have pi halves, and I look at a unit circle, and I'm like, pi halves, what's the sine of pi halves? If you come up with 1, now we have 1 times 6 is 6, plus 4 is 10. And I'm going to double check real quick. So when I plugged in a pi halves, I get out a 10. Okay? I'm definitely going to check one more thing, just to make sure. I'm going to check a pi value. I should be getting negative 2, but we will do the math out, okay? So if I pick a pi value, and I plug it in, where am I now? Ignore all this here, right? If I pick a pi value, 2 times pi is 2 pi minus pi halves, right? So now I have, where am I? Sorry, I keep running out of room. Where can I write? Just give me 1 second. So here we go. Here we go. I'm going to plug in that pi right now. So 2 times pi is 2 pi. So I have 2 pi minus pi halves. Well, 2, common denominator, can I just say 4 pi halves? 4 pi minus 1 pi is 3 pi. 3 pi halves. So if I look on a unit circle real quick, 3 pi halves, I ask for my sine of that. Well, isn't that going to be negative 1? Now I have negative 1 times 6, which is negative 6 plus 4. Negative 6 plus 4 is negative 2. Now I'm going to double check right here. At pi, did I get negative 2? And I think we did. So we're good. Okay? Now the other possibility, because a teacher might say, I want a cosine value out of this. Well, we just have to think a little bit differently now. Okay, I'm going to get rid of my phase shift and we're going to look at everything else. Okay? So let's use orange for a second, if I can. Now right here, okay, right there, I know I'm not perfectly neat, but right there is definitely a cosine function, right? Starts high, ends high. Now if I look, a lot of things are going to match up. My vertical shift was still my vertical shift. My amplitude was still my amplitude. Okay? Now my phase shift is what changed. If I look at my phase shift, it looks like I moved over an entire pi halves. Okay? So I'm going to write here my phase shift is pi halves. Now my period from pi halves to 3 pi halves still looks like it's encompassed within a, let's double check, okay? If I go to pi halves and I go to 3 pi halves, that still is definitely a pi, right? So now I got to think a little bit different and just go to it, okay? So let's use that information and I'll keep writing, okay? Why don't we say y equals amplitude is 6, cosine, I know something's there, I know my vertical shift is plus 4. Now since I know we had a phase shift of positive pi halves, that must have been negative. Does that make sense? Okay? And I forgot what I was saying. Let me make sure because I just looked around. Negative, yeah, okay, we're good. Now, since we still know the standard period with 2 pi, I must have divided the pi 2 to get pi for my period. That means this must have been a multiplier. Okay? So I'm going to have 2x minus pi. 2x minus pi. Does that make sense? If that is unclear, let me just prove it backwards one more time. Well, if you've watched 7 minutes, you can watch 9, I guess. So if we want to take this and say, oh, I wonder what everything was, I'm going to factor out a 2, right? So if I take out a 2, that's x minus pi halves, correct? And we double check. Well, 2 pi divided by 2, well, it gives me pi. That checked out. And pi halves, everything moved over pi halves to the right. That checks out. Okay? So let me double check and just show you how to do that again to make sure. Okay? You always want to, if you have it has to be right and you want to be careful, just make an XY table. And then you can't be wrong, right? I guess you could, but it'd be much harder to do so. No reason to plug anything different. Why don't we just check a pi halves and see what we get? Here we go. Pi halves. So if I say 2 times pi halves, I get pi. Pi minus pi is 0. So I look in the unit circle at 0, and I say the cosine of 0, I get 1, right? 1 times 6 is 6. 6 plus 4 is 10. So at pi halves, did I get 10? Yes, I did. So I'm going to try another one. It doesn't matter. I mean, let's check right here. Okay? So let's see. Between pi halves and pi, I could look right here if I wasn't sure. Pi halves and pi, wouldn't that be 1/4, 2/4, 3/4? So why don't we check a 3 pi fourths? Okay? Like I said, it doesn't really matter what you check if you're thinking carefully. So now I have 2, that 2, times 3 pi fourths is 6 pi fourths or 3 pi halves. So if I have 3 pi halves minus pi, isn't that really 2 over 2? 3 minus 2 is 1, so I get pi halves. Okay? The cosine of pi halves, well, that's pi halves, right? Well, the cosine of pi halves is what? 0. 0 times 6 is 0, and 0 plus 4 is 4. So at right here, it looks like I get that, and I'm good. Now keep in mind, there are really pretty much infinite possibilities for this. I could have had a negative, and it could have been reflected, and it could have been, see what I'm saying? But for the purposes of coming up with a period and a phase shift and a sine and cosine, this would be the way to go. Okay? Good job.